AI Director and in the Deakin Cyber Security Strategical Research Center. He serves as the chair for IEEE Task Force on Educational Data Mining 2020-2023 and on the IEEE Data Mining and Big Data Analysis Technical Committee. IEEE Enterprise Information Systems Technical Committee. He is the editor of Springer's CCIS series and on the editorial board of prestigious journals including Decision Support Systems, Cybersecurity. He also serves the Travel Research, Asia Pacific Journal of Tourism Research and Information Technology and Tourism. He is an internationally recognized expert in data science, data privacy and business intelligence. His research has been funded by various agencies including ARCLP, India's Spark Scheme and Hong Kong GRI. He has co-authored 10 papers that won Best Paper prizes, including Springer's IPNM Journal 2023, Best PhD Paper Award winner, IT&T Journal Paper of the Year 2017, 2023, 2007, Nightingale Prize by Springer, etc. The title of the talk, Strategic Suppression of Cyber Propaganda. Cyber propaganda has become the potent weapon for influencing public perception on online social networks, exploiting both individual cognitive biases and the complex topologies of these networks. Traditional countermeasures often rely on continuous control strategies, which may not be sufficient for addressing the dynamic and evolving nature of cyber propaganda. This keynote provides an interview of cyber warfare and then introduces the approach based on propagation module and game theory. A novel hybrid control framework is introduced to effectively suppress cyber propaganda. We also address the dual challenge of propaganda, dissemination and counter-propaganda efforts, recognizing the need for strategic inventions that balance cost and impact. Experimental validations across various OSNs confirm that our strategy profiles surpass others in cost effectiveness. Related work has been recently published in IEEE Transactions on Information Forensics and Security. So, very warm welcome, sir. Very happy that you are with us. And I also want to welcome Ms. Fan, Gangli's sister. Welcome to you also. So, now to all you, you can hear.
Thank you, Steve, for a very warm welcome and a very nice word. And also, thank you all for your interest in this topic. We all know that nowadays it's a cyber, we call it a cyber era, and then we have seen so many different kinds of events happen. But we also see a lot of incidents happening in the past decade. Today's talk, we are going to focus on one small part in the cybersecurity area, but as Sunil mentioned, and maybe as an AI researcher. And nowadays we have a lot of things involved AI. For example, we might have heard about something, but as we learn, people put some kind of poison data into the training data set. But the more that they train, they didn't learn the thing we want them to know. That is one kind of things. Another kind of things, they can use AI to write and university, as AU, like associate professor here in Mpcit. She's working at AU, that is Australia's #1 or #2 university, always ranked at top 20 or 30 in the world. So the research work in my lab, I can group them into three major things. One is called as AI in open environment. This is mainly the work I collaborate with Ashwin Kumar. We know that when we have the data set which is invalid, that means the distribution in your training data set is the same as those distributions you are going to see in the real world. Now we consider this kind of machine learning task as a closed chapter. We say, there's not much to investigate. Most of the problem we want to solve, we already solved it. But that's different. When the data change, and then the train mode, whether we can still use it, whether we can fine-tune it such that it can be still reliably applied. We don't know. Okay? For example, every day we have new malware coming into the cyberspace. If you have a cyberspace, this kind of malware detector, the more you train up to the day, it may not be reliably detect any kind of new emerging malware let's say, if I disconnect my network from the internet, it might be safer. But not all the time it will be safe. Let me know what power grid. They have those kind of systems. So you might have a smart meter at home. And this is a final end of it. And through this kind of say devices, potentially it can also get in. Okay? So that is something we should be aware of. And I believe that nowadays it's very important. It's very important for us to be aware of this kind of say potential risk. And then during the COVID time, Israel's water system, they found that there were some kind of camps to automate the chemistry level and water supply. And then this one believed to be some kind of say risk to the public health, of course also to the infrastructure. And all of these kind of attacks, they are launched from cyberspace. And we realize that there are a lot of things which now attract attention. And the cyberspace war seems very different from the traditional war. And for cyberspace war, we know that you don't know where the enemy comes from. Okay? It's from inside or outside. That's the first thing you have to find out. Second thing is, if expert, who is the person behind it? Where's the source? It's really difficult to know. But for the real traditional war, okay, get attacked from whatever places. And then weapons, also the lethal weapons. However, for cyberspace, it could be just some kind of software, it could be some kind of script. And also be aware of one more thing. If you understand the concept of adversely machine learning, you may know there's something called data poisoning. Data poisoning means they have some poison, they have some kind of data set. This kind of data set you use it to train your system. Your system got crashed. Okay? Maybe potentially got crashed. Or then they say they don't get crashed, but they got poison. Poison means use an auto driving system. You may find that when they see a stop sign, they may become accelerated. And there was some kind of say case that you can find in the internet that will show this is possible. So this kind of things is not script-based attack, it's just data-based attack. So that is something new, but people in general they don't highlight that much, that we should be aware of this kind of risk. So cyber war is an emerging type of warfare, and of course in this kind of cyberspace, defense operation and defense operation that all could be possible there. There are many different kinds of cyberspace attackers. If you are in the cyberspace, And then Russia's, I would say, IRA, that's Internet Research Agency. They found that it's the most well-known one, and that is believed that involved in 2016 US president election, things like that. So what is the Troll Farm? Troll Farm just on the social network. They have many different accounts, but you are not sure whether these kind of accounts they are a real person behind. We call it human trolls. They could also be bots, that's automated accounts. They can, because like Twitter or X, most of behaviors, they generate some message post them, or they find some kind of things, they just retweet it them, or they upload or download. That is the thing they need to do. This can be automated. So if they want to change the public opinion, potentially they can use this kind of strategy to change the opinion. And I will have to mention one thing. Do you believe that there's only troll farm in Russia? Even the cat group, even those kind of things like malware, you may see there are many different malware. They will say the malware coming from Russia, malware coming from China, malware coming from the, I would say, even India, and then they're coming from that. You will find lower claim that there's any kind of malware from the United States, or the troll farm from the United States. You'll find it's very rare, but I don't think you believe that. Just because they are, the message you receive mostly is from one side, you can see that. I would say everywhere, and maybe even more as in the North America, they have different troll farm or attack. But you think about, this is something that's we observe on the internet. Of course, you saw a lot of this kind of news item about this in 2016, that they will try to shape public opinions. And then, what is this all? That's barcode. You may want to take barcode, and then you can read the full story. I think it's from BBC. They said at the beginning of the war, Russia, they have this kind of, say, as a news item, and also effective is very important. Another important thing is that we have a dual competition. Dual competition is this is different from academic as control. Academic control, virus are attacking us with defense ourselves. But in the cyberspace, we are attacking us, we are also attacking you, but at the same time we also do defense. So that is slightly different. And then the method behind it, I would say mainly come from as a two major area. The first thing we want to know is we want to know how those kind of things, objects, are spread. This kind of object could be many things. For example, like we have computer virus, computer malware, you have the social network, rumors, disinformation. It could also have some other kind of attacking strategy will be distributed here or there. But the first thing we want to know is how can we know the objects is going to spread? It's going to spread. The object could be anything, attacking, virus, malware, disinformation, all this word of mouth thing. So we need to know this and also see mathematically whether there's any kind of conditions under which we can know that it can be controlled or persist. And the other is whether we can come up with some control strategies such that you minimize the other side as an attacking effect, but also maximize your own thing. So that's two major problems that are behind it. For the first problem, we want to uncover the propagation as a whole. The method coming from the area we call it as a network propagation model. It's a traditional kind of model which has been used significantly in a lot of disciplines. For example, we might have those things like network flow analysis, and for the traffic design, and also for the academic asset distribution, and also see this kind of propagation. So what they normally do is they are just trying to find out what is the topology of it. Whether the node is connected to every other node, or whether it's only close to the neighbors, or whether there's a different kind of structure. So the hub would be different kind of servers. And then they have this kind of topology. And then we have the objective oriented here. How many hops away will be spread to the neighbors? And then whether the neighbors will be doing some other with the spread or with the spread. Or whether there's any kind of, say, mitigation strategy, like the vaccination to prevent the spread, or whether we have any kind of medicine to cure it, recover it. So there are many different kinds of ways which can help us to do so. In general, the method is they want to find out all these kind of available nodes. They group them based on their status. For example, we may have the COVID, we can have a healthy person, we have a sick person, we have the vaccinated person, maybe from vaccination, maybe from your own infection before. So there are different kind of stages. For computer, we have a secure one, we have a compromised one, we have a computer with a packet with a series file, so that they will not be easy to get attacked. And then we have many different assumptions for it. And we can assume we may not be able to reach it. For example, like say, if you are controlled epidemic, like COVID, and infection rate, for example, is 1 to 20, but then for vaccination, it's very low, and it takes time to do it. When you do the vaccination, you also spread it in some way. So it's less than that. You'll see that you will never be able to reach that status that vaccination rate is higher than the spread rate. You may never reach it. So, in many situations, we want to see how can we control it with a better method. So this kind of method we call it propagation control. Okay? Propagation control, sometimes we say that we have to reach that one, vaccination rate, say 60% or 70%, and then we never be able to reach that. So what we can do, we have to see what are the other things we can push such that we can achieve at some kind of equilibrium rate. So key issue in the propagation control is we need to model who can control and what can be controlled, and how many players in that scenario. And the players, sometimes there's only one player, just like COVID said, that's us. We human as one player. Virus is another one. At least we don't understand them, or we don't understand it clearly, but we have one player. But in the cyber war, we have two players. You are attacking me, I'm also attacking you. We are all defense in some way. But we may have triple party, they are attacking each other. But you may do with one temporarily. So there are many different kinds of things related. And then the method behind it, I would like to say, if you have noticed one, I want to mention this one. We call it game theory. Game theory is starting from 1960s and until now. I believe most of the economists and business students develop it. But control, if you are doing the automation and control, you may also learn it. There are a lot of different games, and the key strategies, we never assume the other players that stupid. Okay? And we never assume they will overlook it. And we assume they are as smart, or if not smarter than us, they should be as smart as us. So in this kind of situation, what we can do? There are many models, like I say, rock, paper, and the scissors models, or for instance, in MRTs are very famous. They also have the chicken. The chicken just said two drivers just driving against each other. Whoever swerve out of the way, that's the loser. Okay? And whoever keep going, that's the winner. But then, of course, then either both of them lose, or one of them that's a winner. So what is strategy you should play in this kind of game? You find it's interesting, so spend some time to do this kind of game theory. There are many different kind of variants of game theory after the 1960s. For example, we may have the game to be cooperative or not cooperative, and we can have the information like a complete or incomplete, or the model to be the perfect or not perfect, or dynamic or there are many different things. I don't want to enumerate, but I highlight some of those. In the game theory, there are the following kind of terms. The first term, of course, is players. One player. Sometimes we have one player. COVID control is one player. And then the wall, at least there will be two players. Second thing is actions. What kind of things we can do for attacking? What kind of things we can do for defense? And then next one, strategy. Strategy, I say, how we are going to do it. For example, like say, block pepper and then the scissors. You can say, I always use paper. Okay. Every time you use paper. That's all. The other is, I will always follow you. If you use pepper, I will paper, I will use what? I will not use scissors, I will use the other one. The one that I don't win. I always use this one. But then you can see there are different kinds of, say, strategies that you may follow. And then there are two strategies and two strategies. Pure strategy, theoretically, people may prove that pure strategy will always disadvantage the position. For people who know it, know the war, know the game very well, and then they may say, okay, in this kind of situation, 80% I'm going to use this one, but 10% I use the other strategy, the other one I use the other. So this is the one. Finally, we call it mixed strategy. So This is strategy part. And then the other thing is payoff. Payoff just means what is the benefit if I do this? Because your action, you cost resources, and you get benefit. But just like COVID, you get the vaccination spread it around, and then you have resources as cost. But then you may have the benefit, but you may say, okay, this can benefit. If you say one more person, and that will be how much, if you reduce that how much, so you can have the payoff. But this kind of game, as if everyone's your payoff is the other people's rules, there are people that zero-sum game, or sometimes non-zero-sum game. So this is payoff part. So payoff is very important thing, but the problem for us is sometimes you just don't know what is the other side's payoff. If the other side has infinite resources, you may find that it's very difficult for you to beat it. Just like if you are running a restaurant, the other side running a restaurant, you are defaming each other, let's say downvote the other side, but then you will find that maybe that's not the best strategy. And then we have the other kind of information, and whether you understand everyone's has a payoff, everyone's strategy set, whether the game will be perfect, and then we can have the action. There are a lot of things that just keep this one, but now one very important concept we call as equilibrium. Equilibrium just say, for any kind of war, there's always some kind of status, and that status, that's the best for both sides. If they change their strategy, they will lose. They will have less profit. So they will stick to this strategy, and then both stick together. So that's the concept called large equilibrium. If you remember the movie, Hollywood movie, they call it The Beautiful Mind. Okay? Lash was a professor in Princeton, and then I think he got some mental problem. I would say he really got some mental problem. But then in his mind, he come up with this really beautiful theories about game theory, about equilibrium. And then that is some part as what is that complete game, large equilibrium. So that's the stage that you want to reach, such that, okay, no, I want to move, and then we just stay at that status. And as for how to do that, how do you push us into that kind of strategy? And one of the methods from control theory from the automation is the optimal control problem. Nowadays, I think many of us just know too much about reinforcement learning, using learning to learn. But learning, we assume that you have the historical data as a training. But when we have no training data set at all, you are facing a new problem, and how can you do this? Optimal control theory is why we do this. For example, like we want to control aircraft, such that if you're riding or close to the state we want, we use this one. But when we talk about optimal control, we only have one player. When we are talking about a game, we have at least two players. So we have another thing very similar to optimal control, but can consider the model of two games. We call it as a differential game. Okay? Differential game is one of the new part of game theory. I would say Mpcit the game theory. If you want to cover it, that's 100 hours course material, so it's too much. But concept, I hope you know, it is roughly like this. So differential game is we assume that we are players. The players are against each other in some way. They jointly control the status of the system. And then your payoff is depending on the accumulation of history. What do you need, what do you get at different stages. So mathematical model, they involve something like this payoff. This payoff is the iteration of the thing along the time. So if the opening comes as one player, and then this is dynamic that is related to the action of yours, but also related to the action of others. When we have the differential game, I would say compare the same. But just the differential game allow you just to maximize two parties. That party might formulate as a video game or other problem, and then find out optimization problem. So that is a typical strategy for people to do this. And then there are other kind of game which you know well, like a video game, radio game, YouTube game, and another game. But now let's have a look at our case study. The first case study that we are interested in is for this kind of cyberspace, for whatever kind of, say propaganda occurred on the online network, whether we can formulate a cost-effective way to do it, or whether we have some kind of method to push it such that we will have less damage to us. So that is cyber propagation war. And our method is we try to formulate all these people on the internet, they know values for this kind of attack or defense. I wanted to say maybe this part is more interesting. I would say here, in this model we formulate the users of the social network. There are maybe it's like 4 kinds of users. The first one is ignorant. You never heard about this before, but then that's you. Okay? And then when you heard about it, there are 2 actions. One is a web spread. Okay? You know that's easy information. But if you are in the actual telephone group or profile, you spread it because you may be paid to do it. Right? So that's a web spread. Another is a web spread. That is the people. They don't know whether it's true or false, they just think it's interesting, they spread. But action is the same. However, this group, you can use media education, literacy education to do it, to reduce it. This one you can, or web spread you can, because they are paid to do it. I know it's wrong, but I will spread. Okay? This one is, I'm not sure it's wrong or true, I just find it interesting, I spread. Okay? This one you use education to do it, but this one you can. The other one is stifle. Stifle maybe people like me. Whatever information I read, I just read. I don't vote. I don't upload. I don't download. I read. That's it. So the information is all terminated at this point. So you can see on the internet, you can see many different kind of people. But one way is to do this kind of research is you find out how many different kind of people involved inside, and then what might be the control problem, and we try to do the control problem. We call it impulse control. Because for those kind of social network, you may say, I will deploy one staff member that is 24/7, monitoring the online rumors about your institute. But the thing is, whether it's worthy or not, whether the data is really that huge so that you can pay 2 or 3 staff members salary or whatever. So you have to do it more efficiently. One of the efficiencies, we don't need to do it every day, but we just have some kind of regular pattern to do it. So we call it impulse control. In impulse control, there's some kind of mathematical problem defined there, and we also formulate as an optimization problem here. I would say as big math. And then we come up with a strategy to say, we don't do it every day. It's not continuous as monitoring. We can use impulse the method that we got is this kind of formula, and then we can see some of the results. This is strategy. I would say you have some kind of pattern to do it. Of course, at the very beginning, you may have more resources to do the defense or the attack. But later on, you will not just minor one, and that's it. The other side of it, the best for them is to do the same thing. If they're smart, they do the same thing. If they're not smart, this one will win. If they're smart, they do the same thing. Okay? So that is the strategy we have. And then across the way, you can see that all this kind of, say, information they want to press, as a spread, it's decreasing, but then the information they want to mitigate is decreasing. But then finally they arrive at something which is stable. So that is smart people, they will do this, and also So that is a new control. Finally, that's philosophy. I want to say the thing we just talked about, they're all about cyberspace, but not cyberspace. Okay? Don't limit to the cyberspace. Because we can see for the business, and we can have this, say, advertisement war. You may have heard about Pepsi, and then Coke, and then in some way they do this. And then we have one more company that says they want to do the kind of promotion, kind of, say, campaign. It is a war. And this kind of war, of course, they limit your action. You cannot be unethically deflate the other person's product. But you have to think about what's the way to spread your own message. And then you can also use this kind of strategy to the border. I think the recipe I provided, one is for propagation, another one is for the control. Still, these two recipe are still valid because you can see all these three papers, they're in the number one journal. Okay? If you are working in the cybersecurity, this is number one journal in the world. And then there's a reason that there are quite a lot of paper published there. And the same kind of methodology, but even more. I think we can stop here. Thank you. And maybe we see any questions.
Any questions from the audience?
Yes.
Referring to your talk yesterday, you told and highlighted explicitly that you find a difficulty where you can't differentiate between the deepfakes and audio. Deepfaking audio is vaguely available everywhere, that any layman without even the programming background can deepfake someone's audio. My question is that since you being the AI research, so is that so difficult to reverse engineer the process and find out whether this is AI deepfake or the original one? Because some recent incidents taking place in the country where the accused one was claiming it was fake, but still the legal system or the team behind it took months and months, and eventually that got overshadowed in the media space. So considering this as cyber propaganda, we can't avoid it. It is happening all time. If game theory means attacking is always there, instead of defending, can we think of a space where it is easy to reverse engineer and find out?
I would say technically, you want to detect there's a deepfake. Technically, it might not be possible. It might not. For now, it's possible. But you see the technology development, like I said, generated by AI, then become, again, the purpose of this training is make sure that you cannot differentiate. So it may be a couple of years later, there's no way to really differentiate. If we consider this kind of thing, I would say we cannot depend on those kind of technology to tell us. We have to have the tools from the host, but the accuracy is not high. And then just like generated AI, they come in word. Sometimes we just don't know your assignment was written by you or written by ChatGPT. We don't know. But the strategy might be we should leverage it, and then we should live with it, rather than just against it. So for deepfake, of course, if you consider it as a kind of cyber war, what you might do is you cannot defend it, you have to counterattack it, and you have to clarify your information just like at the beginning of this war, and then they say, okay, the president flew out of the capital, flew out of the country. Of course, no matter that's true, of course, it may be deepfake generated, but it may be launched by a real person, right? So that you consider that one as disinformation, you have to clarify your own action. So that is from a game theory point of view, you either live with it, or leverage it, or counterattack it. But then you have to be smart about what is your strategy for it, so that your profit will be as high as possible.
So with respect to text reference, you told that if essay is written by ChatGPT or me, we can't differentiate. But we have an open source model which differentiates that this is AI generated text or written by a human. Like it was flowing all over the internet. It is open, available everywhere. Like Undetectable by AI was the site which received most number of clicks in one, where they generally started tweaking the words. Like if the ChatGPT model which I'm using or any generative AI model which I'm using is trained by British English, let's say UK English, then it started detecting some words like thrill, schedule and all those stuff, then vaguely consider this is AI generated. If those words are not utilized and not matching to the region where I am searching this, then they told that this is humanized way.
But if I just say I love you, you know whether it's generated by AI or by me. Just put a symbol, you don't know. Very brief, maybe I hate you, but generally I say I love you. That's an easy one, maybe easy one, but we cannot have. So we cannot say, for now, here there's some kind of room for automation tools to detect it. But in the long term, we should not depend on it because it's unlikely. The generative AI is trying to make it as real as possible. Very good question.
Thank you.
If there are no further questions, even we can have it during the lunch. If any further questions. Without further ado, let us go for the next lecture. Before that, I thank Dr. Gangley. Presentation on cyber propaganda, which is our area of interest also. It is my cup of tea. So I was mostly I am very happy that in my area some attack related presentation was there by an international speaker. Thank you so much for raising the occasion.
Thank you.
Now the next speaker is from a very renowned, well-known industry, Mpcit, Associate Vice President of Mpcit, Mrs. Jnnce. A big round of applause. Please, ma'am. During some technical issues have been solved related to the presentation. I request Mr. Sunil MD to introduce Dr. Jnnce.
I'm here to read out the introduction of Dr. Jnnce, Associate Vice President, Mpcit, Bengaluru. Jnnce is Associate Vice President, Unit Technology Officer, Global Head of Technology and Architecture Practice, Communications, Technology, Business, Process. Priya has 31 plus years of experience in telecom and IT. She contributes to youth strategy, drives technology adoption for solutions across various programs globally. She has been driving digital transformation, open digital architecture, IT roadmap, cloud migration, open source adaptation, AI strategy, 5G use cases and industry solutions, data modernization, legacy, technology of modernization, innovation, guiding various transformations and modernization programs for CMP Global Clients and part of Mpcit Technology Council. She recently received Leadership Award from Analytics India magazine, the Rising 2024 event. Technologist of the Year Award at ICWITE 2022 by IEEE, Women's Icons Asia Technology Award 2022 by Women's Icon Network Singapore, Top 10 Women Tech Leaders India Award 2022 by Reva University. Previously received Outstanding Achievement Award under her guidance and drive. Mpcit has won 17 Outstanding Catalyst Team Awards in TM Forum. She received Individual Recognition Award Marketplace to ZTP Edge 5G Technology Reports Reference Architecture. She is a speaker in multiple industry and technology forums. She received Best Technical Presentation Award by Society of Petroleum Engineers as part of India 5G Hackathon. Two of the solutions recognized in top 10 in Ministers Conclave, 5G use case discussions with Department of Telecommunication, Ministries of Vertical Industries, contributed to India 6G vision paper. She is in the governing board of Linux Foundation Networking, senior IEEE member, IEEE Comms of Vice Chair, Bangalore chapter, IEEE WIE member, IEEE Fellow Institute of Engineers. She has co-authored book on digital signal processing, first and second editions published in McGraw-Hill, international edition translated to Mandarin. That's a distinguished personality with us. Very happy to have you with us now. And over to you. You can take it now, please.
Hello everyone. Good afternoon. Organization means for the opportunity to meet you and also discuss about innovation. communication. But I will just take one example here. Okay, this is again for network plan. Right. So any network for that matter, right? Like it's not that I have set up the network and everything is done, right? So day zero, while setting up the network, after the network is set up, right? Like day 1, day 2, day 3, day, etc. There used to be like a lot of configurations that needs to be done, right? So that's why it's the life of a network engineer, how you can actually like piece that with the or amplify
questions from the audience? Yeah, if there is no questions, Madam, thank you so much for coming all the way from Bangalore here. We are proud that two big figures are here. IEEE Comsop chair is here, who will be delivering his next lecture in the post-lunch. IEEE Comsop chair-elect vice chair is here. She will be the IEEE Comsop chair 2025. So we are proud that both of the IEEE Comsop office bearers are gracing our international conference. Thank you so much, Madam, for your very nice presentations. And the discussions were going on related to the selection of the topics, the amount of very honest efforts which have been put for this particular talk. Immediately when I offered the invited talk to Madam, she gave the list of topics and thrown the ball to me. Sir, now it is your job. You select whatever you want. So I thought a general topic which really give a spark in, raises a spark in students' mind. I thought innovation mindset would be the very nice topic which the madam can present, because an industry person presenting innovation, actually our students group really should be lucky. Being Saturday, all of you are here. I am very happy that my effort bringing all the speakers here really fulfilled, because the students are here. Who will definitely Thank you so much. Yeah.
And I tell you, right, like as a student, if you are sitting here, right, like many times I tell you what kind of coding discussions happening, etc. But I tell you, when you get into the profession, that is when you will realize, okay, like so much of opportunities were available for me, and how much really I utilized, right? So these are two inputs that we are sharing from industry perspective, because this is what the industry will expect. Because this is not what you are learning day in, day out, right? Like you are learning the fundamentals, right? But the applied solution is what is expected in the industry, right? Like whether you are working on an R&D organization or whether you are working on the IT kind of solutions, etc., engineering or IT, everywhere, right? Like you will need that applied part, right? So that is why it is important for you to actually like understand what the industry really needs. Okay? Anyway, thanks for the opportunity.
Just to make one more point, when we were booking the tickets were not available. Madam asked whether virtual is okay. So I told, not at all possible. Somehow we'll see that you will be here. So by God's grace, once again we were successful in booking the ticket and ticket confirmed. So just I am sharing when we are organizing such event, the challenges come. We are interested in something, but something happens. But anyway, we are successful. Thank you once again. The post-lunch session would exactly start at 1:55. So I request all my student friends and all the delegates to be here exactly by 1:50, so that we can start the paper presentation session. Later at 3 o'clock, the last invited talk from Anindya Saha, chair of IEEE Comsop. So this is the post-lunch agenda. Please be here by 1:50. Lunch is arranged at the library cellar where we had served yesterday. Thank you so much.
So I will go a little bit into details of what is going on in wireless communication. So this is, and I will also touch upon some new things which are happening, which will also tell you why machine learning you should continue to understand and study. But if you want to do it, you should not do it blindly. You should do it with some purpose, with some fundamentals of communication being present with you. Then you will probably be much more benefit, much more successful. Okay, so this is just a snapshot of what is called as the 5G hexagon. This kind of a graph or this kind of a diagram is given by IT. And this says the laser pointer. And what they do is they show, you can see various vertices here. Okay, one, you can see peak data rate. See my hand. Okay, so it's not visible here. You can see peak data rate, user experience data rate, spectrum efficiency. So these are all key parameters. I no, I'll just use the pointer and not use the pointer is this one. So you can see a lot of these KPIs which are there, and all these KPIs are basically kind of metrics given by the IT. IT is one body which defines the requirements. So when 5G standard was done, this is what is required. These were requirements given, and you can see high connection density. So if you look at whatever I have written before, there are basically 3 types of traffic. One is enhanced mobile broadband, which means you want more and more bandwidth for a lot of the media applications, doing more video calls. Then you have more machine type of communications, and then ultra reliable. So machine type communications means if you look at 5G, this is one of the important things which happened. Like you had more machines which got connected, okay, rather than people being connected. People of course were connected, but this was a big change from when we took the generation from 4G to 5G. So 5G is basically touted as a technology where there are more connected things. And going to 6G, and this is what I am showing here, is basically the diagram which IT is given a set of requirements. And I am not going to go into a lot of detail on this, but what I wanted to show you are 2 things. One is that you have integrated AI and communication, which means that the next generation of standard is kind of considering AI, machine learning as an integral, or they call it AI, which means it will be pretty much part of the standard as it comes up. It is not like it is an afterthought, it is thought from days ago. And there are several new capabilities which are added. They are also used by AI somewhere, and the green one shows all the previous capabilities, but the metrics are enhanced because as you go progress from 4G to 5G, and 5G to 6G, you want to increase the capabilities which are there. There are other some more important capabilities which are added, like integrated sensing and communication, ubiquitous connectivity, which were not there, and largely this triangle, which is part of the 5G, has been enhanced to maybe the defensive communication, massive communication, and again hyper reliability. So everything which was in 5G has been enhanced. Plus AI and AI has become very effective. Okay. So that is one important why everybody who is interested in AI and is interested in communication, 6G is a very good opportunity. So people doing research, people doing projects should look at it as an opportunity to build their skills and go into it deep. So with this background, I wanted to basically say that 6G is for people who want to do more things related to AI. And AI in a nutshell, I think this slide I should skip. It is just there because I usually keep it for people who are not familiar with it. But I kind of see that most of the people here are familiar, have a good familiarity with supervised learning, unsupervised learning, all that, right? So I think I will skip this. This was mainly there for me because I wanted to just show what the different aspects are, what is AI, what is machine learning, deep learning. I think these things people are already aware, so I will not go into it. But I think this is also, I would say, is more like a primer where I have kept what are the different kinds of learning aspects which are there. So you have supervised, where you have labels, the data is classified with labels, and then you have unsupervised where you practically do not have any labels, but you try to extract some kind of a pattern from the given data, then you have reinforced internally. And then finally deep learning where you really give it to a neural kind of model to make the machine behave more like a human being. And one of the important things as people are going to machine learning is there are visual blindly. There are certain metrics, and the lower part of this actually shows these metrics that people are using to kind of evaluate whether if I have a problem at hand, then is it beneficial to use machine learning or should I do it in some other classical way? So there are a lot of metrics which have been evolved, and I think all of those are also well known. So I will not go into too much details. think this is something which looks like people already know here. I will kind of jump into some new, something which has made news very recently. I think this news article came sometime in 13th November. I think you can see the date here, and I think this was mentioned in the previous slide also about what is called AI and Alliance. So for the first time in the history of telecom, these two companies, SoftBank and NVIDIA, they have collaborated to form what is called as an artificial intelligence radio access network. Okay, so I think lot of jargons are there. So what is radio access network? Radio access network is like your cellular network. You have a base station, which is your cell towers, and your user equipment is nothing but your phone. This combination is what is called as an access network or a radio access network. So a lot of places you will find this word RAN, which stands for radio access network. So it is basically the base station and the cell phone, and so many users. So all this is called as the RAN network. And what people have demonstrated is that they have integrated AI capabilities in the network. They have done trials in Japan demonstrating that on the same compute platform, Ganapriya told about compute and communication. So here on the same communication platform, they are able to do AI workloads as well as telecom workloads in the single compute platform. So this is pretty remarkable, happening first time. And people estimate that there is a lot of revenue that telecom operators are going to benefit from this. So ROI means return on investment. I think there are some numbers. Estimation is $5 of AI insurance revenue for every $1 invested. So people are very excited. Telecom operators are excited. Everybody is watching at this. Some people are watching with skepticism. Some people are very optimistic that this will finally take off. And why is NVIDIA here? I think that's a no-brainer because NVIDIA is the company building these GPUs. So it is basically start a very interesting time. RAN in the radio access network, you typically had the big Ericsson, Nokia guys doing it, but a GPU company coming and getting into it is something very unique. And SoftBank also has a whole lot of spectrum and is doing deployment. This is why they came. So this is something which I wanted to put at the beginning, just to say that there is a lot of potential in this domain. When you can think of it as a fusion of telecom and artificial intelligence. Okay? And there are more details on this. If you Google, you will find it. So before diving deep, I wanted to say why people should be interested in this subject. Okay, so now I will go a little bit more deeper, and being mindful of the time, I will go a bit faster also. So, a part of my team works in VGBP standardization, the body which writes specifications for most of the cellular standards, and they make releases. Just like software releases in a company, there are releases, and right now people are working on release 90. But in the previous release, already some work has started in the domain of AI. You can see, performance requirements. People are discussing about what kind of data is used, how do you utilize the networks usefully. And so people are basically building a lot of support structures to bring, the study of AI. So first, whenever we propose something as a standard, what people do is, they first take a study phase where people are studying how things will impact. So people have studied different use cases, like how do you do slicing of different workloads, how do you give benefit to the service experience. So a lot of this, again, to recall the slide which Ganapriya showed on uses of AI, people are discussing. But I will say, to a limited extent, wherever it will impact the specification. How will it impact QoS? You can see one component here for IWDA. So the 5G core already had one of the components which was called as the data analytics function, which was basically a repository of lot of structured data. And here you can see that various other workgroups have also started working on it. So this is just to say a lot of interest is there. I will go a little bit into details of this air interface, which is where my team mainly works. But then you can see that a lot of use cases So this is a little bit more detailed slide. I don't think I can zoom further, but what you can see here is what are the, here we have categorized the different use cases where people are using AI in machine learning. Like first is network management. You can see mobility management, you can see resource scheduling, you can see link parameter prediction, traffic prediction. All these are very commonsensical things which an operator like, let's say, a Reliance or an Airtel would like to use. So they are already being thought of. Then people are also thinking of network management, operational management like QoS monitoring, RAN optimization, intent-based management. Then device-based optimization is also being thought of. Not all of them have come, but this is like the full spectrum. Then in the enhancement side, people are thinking of, so these are the important things which people are thinking to study and take further. Network energy saving, load prediction, beam prediction, PSI feedback management. So some of this I am going to touch upon. And here there are some more things related to security. Security, I think Dr. Lee also spoke about in the morning and talked about security. So essentially if you look at the whole space, it looks like machine learning AI can be used anywhere. Okay. Now coming down to one other concept which is being thought about, this is something which may be a little too early to introduce, so I will just not go into this in detail. There is a concept which is called Open RAN or ORAN, which is being discussed in 5G. What has happened is that after 4G, till the 4G time, the interfaces were very close, especially between radio and the expanding and these interfaces are now being opened up, and it is possible to give visibility into that and also make the data accessible. So what people are doing, especially in the industry, is they have come up with the network management stuff, which is called as the service management orchestration or SMO. And this has two components. One is called as the near real-time RIC and the non-real-time RIC. So RIC stands for RAN Intelligence Controller. And the non-real-time RIC actually works in kind of, you can say, hundreds of milliseconds, and the near real-time RIC works much faster. What they are doing is they have standardized interfaces through which they are collecting data. It is like telemetry of the RAN interfaces, and they are helping in network optimization. So I will just leave it at that. There is a lot of work happening here, but then it needs a little bit more familiarity with the Open RAN. Here, basically they are showing that you have these different interfaces from data is being collected in the E2 termination, and then it is being processed, and there are certain applications which people are building. So just like your Android apps, people are building something called X apps, which are nothing but AI/ML applications, for doing some optimization on the network. So this is something which is happening now, and a lot of people in the industry are working on it. But this is one aspect where AI/ML has already started coming in the existing 5G network through Open RAN. Okay, so some important things which we are looking at, specifically from my group is looking at, and that's why I have put it here. I'll go into a little bit detail in the next slide. Is air interface. So I don't know if people understand what is air interface. So air interface is basically the set of interface signals between as you can say the wave propagates through the air between the RF and between the base station and the user equipment. So the protocols and all. So essentially it relates to all the physical layer proceedings which happen between L1 and the air interface. So there are certain things like CSI feedback, beam management and positioning. So I think this may look a little bit jargon to you, but I will go into a little bit detail in each of them. So these are some of the things which people are looking at. So maybe I'll talk a little bit about CSI first. So if you look at base station and receiver, in this case let's say it is your cell phone or what is called as user equipment. What you have when you consider it in a wireless network, what you have in between is a wireless channel, right? you must have heard about the term channel impulse response. So C here stands for channel, and S stands for state, and I stands for information. Channel, state, information. So whenever a base station transmitter has to talk to a user equipment, it has to make sure that it knows what is the channel in between. Then only it can do a very good job of decoding the bits correctly. So a very simple way the base station does it is by sending some known signals to the user equipment. In this case, it is your phone. The phone knows this is what they expect from the base station, and based on that, it is able to reconstruct how the channel looks like. Okay, so if you kind of go back to your communication theory, the received signal is called Y, and what is transmitted X, then in terms of transformative is Y is equal to X, matrix transformation. So H is your channel impulse response, the channel state. And if you want to recover what was transmitted, you have to know H. So this is what is one of the key things in a communication, any communication between a transmitter and receiver. And we will see how, I will go into the next slide where we will detail out how this is currently being done and how AI is going to help in that. Okay. So if you look at some common terms here, you see one term called prediction, you see one term called compression. You understand the meaning of these terms. So what I will do is, without going a little bit into it, I'll try to give a little bit, develop some intuition. Okay. We will not do math now. Okay. We'll leave the math, we'll develop some intuition so that you get to the feel, and then you can dive deeper into the literature and journals or whatever IEEE transactions you have. Okay. Second one is called beam management. And why am I talking of beam management? So with 5G, one of the important ways in which base station is communicating with user equipment is through a different kind of radio equipment which is called massive MIMO. There are a lot of massive MIMO based radio equipment which are there. And there is a concept called beamforming. So beamforming concept came from the radar world, right? Where you had directed beams to basically do target detection. Now the same concept will be used in 5G cellular network and it will be there in 6G also. So if you look at certain frequencies, where beamforming is used today, it's 3.5 gigahertz. So here the radios are actually emitting beams, and that's what you receive on your phone, and you are able to connect and get very high throughput. Typically, if you look at some of these bands, they have about 100 megahertz of bandwidth. So the throughput is really high, and the way this is working is through a technique called beamforming. Now, when you look at beamforming, so beamforming you first identify as a key technology in 5G. And when you look at beamforming, one of the important things is, am I able to direct the beams properly? Am I able to recognize that the beam is good or what is the quality? So again, I will dive into details, but I wanted to say a few things. One is you can do some kind of beam prediction and also some kind of a spatial or temporal prediction. So this, what is this? Again, I will go into detail in later slides. The third one is called positioning. So typically, today how is positioning done? You have, every phone has a GPS. But in this case, what happens is the base station might like to know what is your location. Okay. And there are various techniques available. But if you couple existing classical techniques with machine learning, the accuracy of prediction can become much more better. And that is what some people are able to show, that it is actually better than classical techniques. So the reason why I put these three are the top ones that are being discussed today in the standard body. And the main reason why a lot of people are spending time on this is because they find that machine learning techniques are exceeding the existing classical techniques. Which is why there is so much interest. Otherwise, why will people waste time on this? Right? Okay, so I will come to this later, but this hold your thought, CSI, DMAT, positioning. Okay, we will have slides in this. Now people are doing some more things. They also are trying to find out, is this, we are doing a lot of machine learning techniques, but then I think all of you already know, one of the drawbacks is there is a lot of compute required. So there is a lot of energy that we spend. So is this really worth it? Is it really giving us the benefit? So people have some metrics. People are looking at, if I do compressing my CSI, am I really saving the overhead? Because whenever you send some reference signals, you are eating apart into the given channel bandwidth. Because we are sending that much time sending known signals. If I send known things, what is the point? I am wasting my bandwidth. So people are trying to see that, hey, I use AI method, am I really saving it or not? And if there is a gain, only then it makes sense to use it. So people have these methods, and they are also looking at, is my accuracy of estimation really good or not? Okay? Because only if it is good can I again make sense out of this. So just like any engineering problem, if you are saying that I will use this to solve it, you want to see if there is any benefit or not. Okay, so that's exactly what people in this standardization do. So there is a evaluation technique for it. And finally, how much media I'm using, how much logs I'm using. I think last session we saw papers and reviewers asking the same thing. So it's a very natural thing for people to understand. Okay, so this is one thing. This is another important thing called network collaboration. Okay, so what is this? So just understand it at a very high level. So in a radio access network, you have the base station, which is your towers, and you have your phone. Now, one of the problems people are discussing is, where am I going to run my AI workload? Am I going to run on base station? Am I going to run here? Or am I going to do partially there and partially here? Am I going to do fully there and nothing here? What am I going to do? Okay. So one of the things which people are looking at, let's say, is because base station has a lot of power and compute space. So maybe I do my entire AI workload and AI inferencing there, and I do very little here. But then if you look at some of the phones, they are also getting more powerful. So maybe some people are thinking that maybe I do partially here and partially here. So there is a terminology coined here which is called as one-sided and two-sided models. So we will come to that. So there are various levels of collaboration. One is the base station and cell phone don't talk to each other. They both predict independently and then they start communicating. So that is called level X collaboration. Level Y, there is some kind of a signaling between the base station and the phone or the user equipment to say this is the kind of model I am using. And by signaling, the user equipment or the phone knows which model to pick up. And so in this case, there is no model transfer, and there is another case when there is a model transfer. So whenever there is a model transfer, obviously there is some kind of handshake, there is some kind of message passing thing happen. So all these things people are discussing, and if you understand how complex this is, the people who manufacture base stations are not the people who make it. They are totally two different kind of companies. So while it will look very obviously very simple to do, it is not simple because the people who control base station manufacturing and who build user equipment are totally different. So it makes the problem very hard. Okay, because they all agree, they have to all agree on a common thing. Only then this can be successful. Okay. Let's say both the manufacturers will say it would have been easier. But that is not the case, unfortunately. Right? Okay, the other thing is life cycle management. This I am not going to do so much here, but this is basically people are discussing from the time of how AI model is developed, how will you deploy it, how will you manage it on the field, when will you discard it, when will you integrate with the new model. So there are various things which are going into it. So I just wanted to show, at a standardization level, what are the aspects people are looking at, okay, before I go into the next detail. If there is any question, you can raise the hand and stop me also. Okay. Okay, so I'll go to the most basic one which I spoke about, which is about CSI enhancement. And let me zoom in a little bit in the first part. So, okay, maybe I don't know if this is visible. Okay, so what I wanted to tell here is the same thing. Let's say a base station wants to, talk to a user equipment or a phone. What it sends first is what is called the reference signals. And whenever you are sending some reference signals, you are eating a part into your downlink bandwidth. Obviously, because you have said, okay, 10% I send reference signals, only rest 90% is my actual payload. So what people are trying to do is they are trying to see, can I compress that? Okay, can I compress that? Now why that 10% reference signal is required is because I want to know this channel H. So here I have kind of tried to show it mathematically. H is basically the impulse response as seen by the user equipment from the base station. Okay. And for this, what they do towards the user equipment, they do some kind of a transform, like singular vector decomposition. If you have read matrices, maybe you know. What people are trying to do with this is they are actually user equipment figures out what kind of channel it is seeing from the base station. But now it has to signal a few things back. It has to tell base station, hey, I am seeing something like this. So it basically gives feedback on 3 important parameters. And those 3 parameters, one is called CQI, which is called channel quality indicator. Then there is something called as the PMI, or the pre-code matrix indicator, and there is something called as the rank indicator. Okay. Now, what are these 3 things? They are basically telling how good the channel is from base station as seen by the Ieee. Okay. When you look at PMI, the PMI is actually telling the base station how it should adjust or how it should pre-code the waveform when it transmits, so that the user equipment can receive it in the best possible way and get the best throughput. And this is the reason why this process is done even now. Okay, so this has been there from 4G days. Base station sends reference signals along with the payload, user equipment, and this is not one. There are so many users in a network. At a time, maybe 1,000, 2,000 users are connected. So everybody keeps getting these reference signals, and every user equipment gives feedback. What are we trying to do here? We are trying to see, can we minimize that feedback? Or even better, can the base station and user equipment magically figure out what the channel is without doing anything? Okay? So it is not a very trivial task, but then there are a lot of things people are doing. So what happened later was, I'll just come to this. There is another stream of thought which people went into, which is called compressive sensing. What is compressive sensing? Compressive sensing is where if you look at the matrix like H, what is H? Channel impulse response is basically, it contains the number of, it is an indication of how many scatters are between the base station and the user equipment. Now if you look at it in an angular, spatial domain, you will see that if I have a base station, if I am in a line of sight, then there is only one channel, there is only one direction. The other directions typically are not affected. So what has been seen lately in some of these studies is that typically these matrices are very sparse. So it makes it very easy for you to compress it. Because in many other directions there is no information. The information is typically very directional. And that is what led people to use what is called compressive sensing. So this was the first place where people came when they wanted to do compression of reference signals. And I think you have heard these terms. There is spatial compression, temporal compression, spatial, temporal. So what is spatial? Spatial means, let's say, if I have many reflectors, when my electromagnetic wave is being propagated from base station and coming to user equipment, I will see only a few reflected paths that way user equipment. I will not see everything. So I will make use of that sparsity to compress the CSI matrix. And that again gives some advantage. The other is temporal. If I look at it in time, my channel will not be changing at all. So really, do I need to keep on sending reference signals again and again? Maybe no. But in some cases you may need to. For example, if you are on a very high speed train, okay, and you are moving at very high speed, maybe then your channel has to change very frequently because you are also moving at high speed. But let's say if the user is stationary and the channel is not changing, maybe it doesn't need to get updated. So all these things are there which help you in compressing the CSI. Now using this, people kind of develop some code books. There was a frequency domain compression also. There is a spatial domain compression. I will not go into details of this, but there are references I will share later. So people finally came to conclusion that if we could do compressive sensing, then the next logical step is to start using neural network based models, and that is exactly what people started doing. Okay, so if you look at this diagram, what we are showing here is that the Ieee somehow figures out the edge based on reference signals. Now it gives you an index, and it is not doing much. It is basically using this compressed information and trying to reconstruct. It is trying to reconstruct using a neural network based model what the channel looks like and inferring the pre-coding vector. So the transmitter with very little information compared to what it needs to be can totally reconstruct how the channel is. It is, sounds very magical, but that is what is the power of machine learning model here. But then this needs an enormous amount of training. Okay? But over a period of time, people have found that let's say a channel is not changing for a long time or number of paths of this, it's possible to do. So there is this notion of what is called as implicit feedback, where you kind of almost know the channel based on past history or something, and very little feedback actually has to come. So the advantage is your throughput of the network increases because you are saving the amount that you spend in overhead. Also, when you are sending some feedback from so many users back to base station, you also cut down a part of the latency. So it also makes the operation faster. Okay, so this is what is called as one-sided, because here you see only base station participating in creating this model and all that. The next is people said, okay, I can do on both sides also. So here what it is doing is here the user equipment is doing the SVD, but then it is using some kind of a sophisticated AI encoder. Right now they call it the variational encoders and all that, to compress the information even further. And somehow on the base station, you magically decompress and you have a good decoder which can give you back the same vector that you started with. So people are using all these techniques to create models. There are models which will run on this, there are models which will run on base station, and they will be able to perfectly reconstruct how the channel is. So this is the study which is going on, and all these kind of models are going to probably come in 6G. So people are discussing how the format is, how much processing is, and I think all of you would be knowing that now phones also have a lot of AI capability, right? So all these things are going to come, and this is going to, and the way it is going to help you is by making sure that my channel state information feedback is really okay. So this is another framework where people are thinking of. So this is what is the next goal, to do AI-enabled channel prediction. So the user equipment or your phone, based on its location or any other factors, maybe it gets a few reference signals and it is able to figure out how to do it. It is able to predict the channel, and based on that prediction, it will basically give very minimal feedback, and the base station is able to reconstruct the entire channel on its own, using AI models. So a lot of this is actually going in that direction where using AI, machine learning techniques, you can completely predict the channel. So this is one of the important activities which is going on, and this is called as the CSI use case. So the important thing is, how do you know this is good? Okay, so that's an important thing. So there are certain metrics. People are looking at certain metrics. One is called as the Nnce, or mean square error, normalized mean square error, then base cosine similarity. So it is a way to say how good my metric is. Okay, and the better the metric is, how close it is in predicting the AI/ML model. I will also go to some graphs. So what people have seen is that how good is this with respect to actual prediction, with respect to actual estimation. So you can see, this is somehow, you can see the red bar actually shows what is the throughput gain in prediction, and the blue one shows what it is without prediction. So you can see in all of them, it is actually exceeding by more than 4% compared to classical method. So this is one of the places where people are identifying that machine learning is giving a real bang for the buck. Okay, so which is why many people in the industry are after this. Okay, so when people are looking at the industry like a 3GG forum where there are operators and handshake makers, they will not go after something which is not useful. So this work item is being done because people are seeing a lot of potential. Okay. So I hope people got a intuitive understanding of reference signals, CSI compression, and the ability for machine learning to predict, and having neural network models accurate base station analysis to do it in a more compressed way. Okay, so another thing is, okay, these are some benchmarks, I am not going to that, but people are looking at, how good the error is. You can see this metric called Nnce. How good is my reconstructed channel compared to the actual channel? And then plot means how much compute I am spending. So, so many models people have worked on. These are available in literature, and then people can decide whether it is, based on the compute and all, people can decide which one to use, and then how much should be in user and how much should be based. Okay, the next use case, I think this I touched upon briefly, as to why it is important, why it has become important in 5G is mainly because in 5G we do what is called massive MIMO. Okay. People have gone very silent. Okay, so massive MIMO radios basically are using a technique which is called beamforming. This was not available earlier in 4G. 4G, some deployments were there, but they were not successful. But in 5G, this is one of the key techniques which is responsible for giving very, very high throughput. So 5G onwards, 6G, beamforming and beam prediction kind of techniques will be there. And what people are finding here is that, okay, so let us kind of try to visualize how, you have a base station and multiple users, how this beamforming works. So if I am standing in place of a base station, I will send one kind of a beam to just scan the users. Okay, it will do what is called as a beam scan. It will find out where the users are, and then the user will start communicating. So it actually has to, if the users are there, the user will respond through what is called as broadcast beam, and then using that, the user will also try to figure out the previous problem, the channel H. Now one of the things happens here when you go to higher frequencies, the beam becomes very narrow. See, earlier when we were at lower frequencies, the beam are wider. One single beam can cover the whole thing. But now when I go to higher frequencies and I am doing very directed throughput, if I give the beam on the right hand side, the left hand side will not get it. Okay? So you see no throughput at all. Now imagine a case where all the users are pulling what do you do then? Then every user is seeing a different channel, which means that with mobility, the user has to keep predicting how the channel is. And when you are doing beamforming, it is very hard. So, one of the good use cases of machine learning in case of beamforming is beam prediction. So, let's say the user on the right hand corner is seeing some channel. Maybe they can observe the channel for some time and start predicting how the channel will behave in the future. But then it is not necessary it will be successful. Okay? Because the channel C is very much dependent on how the waves will get reflected and it will fall on the user equipment. If the user is also moving, it becomes much more complicated, right? So that's what I said, in high mobility environment it is almost impossible to maintain and track. The other thing is there is also a latency. You know, when the user equipment figures out the channel, it also has to feed back, hey, this is the beam which is the best for me, and that's why the base station should send this beam. There is a lot of signaling wastage that happens. So that also, signaling wastage will lead to some amount of degradation in throughput, or I should say latency. So that is also one of the important things why people are thinking of this. So beam prediction and beam management, and people are thinking that if I don't have to modify many things, but I can do some kind of a sophisticated beam prediction, either at the base station or the user equipment, I can simplify things. Okay, so what are people doing? People are doing, I think, very similar to one of the papers presented. You take a data set, you divide it into a trading set and inferencing set, and create a model. So something very similar is being done. So these are the two different types. One is spatial, other is temporal. Spatial means how the beams change with angular directions. Right? You can think of the beam in, what should I call, the r theta phi space. Angular, azimuth, and elevation. These are three coordinate systems. The beam can be represented by any of these three vector combinations, and that is called spatial. Temporal means how it is changing with time. So essentially, if you know these two characteristics and you are able to create a good model, by narrowing down the beam set, which will help you do that, you can do very good beam prediction. That is what. So again, I'm trying to do a very intuitive film, not going into too much details. Okay, here I am going to show a little bit of what people are trying to do. So here it is basically showing that how a user is doing downlink beam prediction. So the base station here in green is trying to send signals to the user equipment, and the user equipment does what is called as an RSRP. So it basically measures power. The user equipment will get power from all the beams, and it will tell, hey, this is the power that I am using. It will feed it back to the base station. Base station, just based on that compressed information, tries to figure out what is the beam that should go to the user. So you can see here, it is doing some AI processing here based on past history, training data set and all that, training beam set. And it will give you a set of, what it will do is it may not be able to give you first pass, that this is the beam. It will give you a set of, let's say, choose between these. And then the user equipment will choose a set, and then this will start using that beam for communicating to the user. But understand this, that in a base station, when it talks to multiple users, there are actually multiple beams going simultaneously. So actually these things are happening in real time from all the users and from all the beams that are going from the base station. So it's a nice process because a lot of latency you are cutting, a lot of this complex processing you are cutting down. So this is again a good use case which CGV has found which is worth working on. Okay, so this, what I am showing on the left side is where model processing is happening on, or prediction is happening on the base station. There is a similar scenario where it can also happen on the user equipment. If your phone is very powerful and it can do the prediction, maybe that can also help do that. So that is what I have shown here. Again, I am not getting into so many details. Yeah, so here I wanted to show some performances. So here what people have found is these are different kind of beams, and you can see AI enabled and non-AI enabled. So you can see that compared to non-AI enabled, which is 10.7% beam accuracy, this is about 63%, about 6x more. Here about slightly better. So different kind with different kind of beams and different kind of methods, people are able to see that the accuracy is pretty good. Also this is another important thing. The difference in the received power, which is seen between the predicted beam and the actual beam, is pretty lower. So which is why again people are looking more at AI enabled methods, because that is going to be better than the classical methods. So these are the observations. It is better accuracy. It is better accuracy. People are observing in AI-based predictions compared to legacy and non-machine learning methods. And performance degradation may be seen for the model. So it is very important that training set is very good. So it is not like everything which you do in machine learning is perfect. You have to make sure you have a good training data set. Okay, third thing which I wanted to talk about is about positioning. In case of positioning, as I told you, what the base station is trying to do is to tell a particular user location of a given UE. Now today, the most common way it does is to find it basically does two things measurement. One is called direction of arrival or time difference of arrival. Then the third one is channel impulse response. So there are certain well-known theory on how direction of arrival and time of arrival should give you some method. But then people are finding that if you use some Ieee model and you use what they are calling a multimodal method, you basically take information from some more sensing equipment, you can get much better positioning. So that is what people are looking at. So there are two ways. One is called as the direct AML positioning. The other is when AIML is helping in positioning. So these are again two things which people are looking at. So the channel. Okay. So why is this so important? If there is a direct line of sight between the base station user equipment, it is very easy to tell the position. But 99% of the time that will not happen. You will be behind a tree or you will be behind a wall. Then how does the electromagnetic wave go? It goes through some reflection. And those kind of paths are called as non-LOS paths, non-line of sight paths. Those are the most challenging ones because through normal methods, you can never get a good position estimate of a user on an LOS channel. So that is why AIML methods are proving to be much useful there. It is able to predict in a much better way. And this is why this topic is being discussed in the standard bodies. Okay, I think this I am not going to detail, but basically there are certain methods. Positioning is being looked at as it could be assisted by base station or by the LMF stands for location manager or location management function. So location management function is actually an entity in the 5G code which gets all this information, but people are also thinking of how to augment them with some kind of an AI modeling technique so that you can do this prediction better. So what will happen is from a user equipment, base station will make several measurements. You give it to the location management function, and the location management function will then make the prediction of where the base station is, where the user equipment is. So these are the three, use cases. There are many more use cases people are looking at, but since this work has just started, so I have listed down many more. And I think if you look at some iterative publications and all that, you will find that I think people have started working on this already. And I will say that if there is a lot of students who are interested in machine learning, get some, augment that with some fundamental knowledge of your communication theory. You can do much more, refined applications based on AI, when you add them with communication. So here, some more things are listed. One is mobility handover enhancement to improve predictive mobility. For example, based on the pattern in which a vehicle is moving or some user activity, can we predict what kind of channel variation it will see? And channel variation is usually captured in the sense of what is called the Doppler spread. So if I can predict that upfront, I can make much better judgments. Similarly, for RS override reduction, this we already spoke about. Beam management, CSI compression, channel estimation also. And then this is another important thing, interference management. See, nowadays, if you look at urban areas, the density of users is very high compared to, you forget the So there is, the base stations are placed so close apart that there is also interference between base station to base station. Okay. Now, how do you solve that? So there are people have invested that you can use machine learning to figure out where the interference is and avoid that or do some smart management. So I think you can, if you want, you can take a picture of this. A lot of these things are being looked at, and again, going into 6G will become very important because now, if you really think of the urban use cases, people are using phones more and more, and it is only going to be more prevalent that as people go to higher data rates, they will see more interference, but then they will also find ways of mitigating or managing that using machine techniques. Here, I've spoken of some more methods. This is basically out-of-band channel state information you can use to know if there is, am I emitting something out of my channel band. I will not go into too much details. This is about another word which is happening in the called full duplex. So here, people are using DNN-based methods to completely reject the interference. Okay, by learning, people are able to, of course, it's a combination of both analog digital and machine learning techniques. People are able to get as good as like 140 dB of prediction, and that will enable a new class of communication enabled, like full duplex. Full duplex, typically, if you look at it, full duplex is only available in TDD. But in TDD, when you have the same band, currently what we use is the half duplex communication, what is called time domain duplex. But once you start implementing full duplex, then you can utilize the channel better, spectral efficiency will increase. So again, here, the idea is that you start using machine learning techniques, you can enable this current, which was not available earlier. Okay, how much time do I have? Done? Okay, I have exceeded. Okay, so I will just go into this a little bit quickly. So basically, this was a part of it where I said that using machine learning now in 6G, people are thinking of deploying waveforms much more intelligently. So what people are thinking of is that there will be some kind of model which is available in the base station or in the infrastructure, which will look at some parameters. The operator will give some parameters, plus it will get parameters from the service, which I call as slices, and then it will also look at the RF environment, and based on that, it can automatically do some kind of suggestion. It can suggest what kind of waveform is supposed to be used. So these kind of ideas are all floating around in terms of 6G. People are calling it a hyper-personalized waveform, based on where you are and what kind of channel you are seeing. I'll do a waveform, the base station will communicate to you in terms of a waveform which suits you the best, and that will be enabled by machine learning techniques. So till 4G, 5G, we did not worry about it, but then as people are thinking of 6G being AI native, all this has suddenly become a possibility. This is one more diagram. I think I will say this is the second last slide, where what people are doing is the entire communication chain, people are replacing with machine learning based signal processing chain, totally. So people are talking of this as we have transmitted call encoding, simple mapping, modulation, all of this will be by some kind of a machine learning based processing block. And in the receiver also, you have synchronization, channel estimation, simulation, all of this instead of the classical way in which it is done, which is maybe like maximum likelihood or maybe using some kind of machine learning. So this is something which people, lot of big companies are working throughout. They call it a fully neural receiver. You know, you are completely using only machine learning based methods to do transmission and complete demodulation or the complete demodulation. Okay, so this is my last slide. So these are the three paradigms which people are discussing today in context of RAN or radio access network. Essentially, it is called as, one is called AI with RAN, which means that you have an infrastructure where you can run workload as well as RAN loads together. One is AI for RAN, which means you are basically using machine learning techniques to improve the the performance of your network. So this is actually this slide I have taken from the AI Alliance. And the other thing is called AI on RAN, which means you basically are on top of the RAN layer, you are basically using running AI applications. So these three vectors is what looks like 6G will go towards, and all these three will flourish more and more. So it is a very good time for communication engineers to embrace machine learning. But the fundamentals of communication are very, very important for people to make significant progress. If your fundamentals are weak, then no point thinking of AI and machine learning with each other. It's like a good marriage of both these subjects. And it is very promising. I showed you that new slide about SoftBank and NVIDIA. This is how the future is very likely going to be. Okay. I think with that I will close now. Any questions? I don't know. Say your thought.
Thank you, sir. Thank you very much for the very nice presentation, very conceptual. And last remark was very important. That same thing was even discussed by Madam Jnana. She was also telling the same thing. Electronics and communication engineers look for IT, but communication along with AI, machine learning and communication, it is a very nice meet. All these three technologies are meeting together and we are coming up with 6G. So with this concluding remark of the session, I once again wholeheartedly thank both the speakers, Jnana and Anindya. I am very proud to say that IEEE ComSoc Bangalore chapter is the technical co-sponsor. All the jargons what are really used in the pamphlets really have been fulfilled, because it is a real technical co-sponsorship, because the people from those chapters are coming here and delivering the talks. Thank you so much. Next, after 1 or 2 minutes, we will be ready for the valedictory program. Then after that, there will be a break and there will be IT. Thank you so much. Please bear with us for another 2 minutes for the logistic arrangements for the valedictory.
Okay. Thank you everyone, and we can talk to you informally.
golden moment of opportunity and catch the good that is in our reach is the great art of life. A very warm good evening to one and all who gathered over here. I, Sheila S., Associate Professor, Department of Ieee, will be the MOC for this event. It is a matter of immense pleasure, pride to stand here before you all this evening. On behalf of Jnnce, I request the President of today's function, Dr. Ieee, Principal Jnnce, to occupy the seat on the dais. Now I request our Honorable Chief Guest, Mr. Anindya Saha, Vice President, Tejas Networks, Bengaluru, to occupy the seat on the dais. Now I request our guest of honor, Ms. Nanapriya C., Associate Vice President, Infosys, Bengaluru, to occupy the seat. Now I request Sri D.G. Ramesh, Treasurer, NES Shivamogga, to occupy the seat on the dais. I request Dr. Vasudeva, Chair, IEEE Manual Subsection and General Chair, Mpcit 2024, to occupy the seat on the dais. Now I request Dr. P. Manjunatha, Dean Academics, Jnnce, Shivamogga, to occupy the seat. And finally, I request Dr. S.C. Satyanarayana, Dean R&D, HOD, Ieee Department, Jnnce, Shivamogga, to occupy their seat. The function of prayer is not to influence God, but rather to change the nature of the one who prays. I like to call upon Ms. Pamini of 7th Ieee to invoke the Almighty.
like to welcome Mr. Anindya Saha, Vice President, Tejas Networks, Bengaluru, for this valedictory program. I extend my warm welcome to Ms. Nanapriya C., Associate Vice President, Infosys Bangalore. I would like to welcome Shri D.G. Ramesh, Treasurer, NES Shivamogga. I wholeheartedly welcome Dr. Vasudeva, Chair, IEEE MSS. I heartily welcome our Principal, Dr. Y. Vijay Kumar, for this valedictory. I welcome Dr. Manjunath P., Dean Academics, Jnnce Shivamogga. I would like to welcome Dr. S.V. Satyanarayana, Dean R&D, HOD, and also the organizing chair of this conference. Thank you.
Thank you, Darshan. And also I welcome all of you for participating in this valedictory function. Now I call upon Dr. Shati Pramod Kumar, Associate Professor, Department of Ieee, to give a brief insight of this two-day International Conference Mpcit 2024 for the gathering.
Let me present the report of Mpcit 2024, the fourth International Conference on Multiprocessing, Communications and Information Technology. Mpcit 2024 has been organized by Department of Electronics and Communication Engineering in association with IEEE Bengaluru section, IEEE Mangaluru subsection, IEEE ComSoc Bengaluru chapter, IEEE Shivamogga subcenter, Jnnce IEEE student branch, Jnnce ComSoc student chapter during December 13th and 14th, 2024. Dr. S.V. Satyanarayana, HOD and Dean R&D is the organizing chair of the event, and Dr. S. Pramod Kumar and Dr. Sheila S. are the conference coordinators. Altogether, 333 papers were received under the three tabs: Multimedia Processing, Communication and Information Technology. About 102 papers were accepted after thorough review, meticulously coordinated by track chairs. Finally, about 60 papers were registered for presentation during the conference. The registered papers will be published in IEEE Explore Digital Library. The conference was inaugurated in presence of Sri T. Srinivas, Professor, IISc Bengaluru, Chair, IEEE Bengaluru section, Dr. Gangley, Deakin University, Australia, Dr. Vasudeva, Chair, IEEE Mangaluru subsection, Sri G.S. Narayana Rao, President, NES, Sri S.N. Nagaraja, Secretary, NES, Dr. Y. Vijay Kumar, Principal, Jnnce, Dr. Manjunath P., Principal and Dean Academics, and Dr. S.V. Satyanarayana, HOD and Dean R&D. In initial remarks, Dr. S.V. Satyanarayana welcomed all the guests and the participants and presented a brief walkthrough about the schedule of the invited talks and the paper presentations. Sri T. Srinivas, in his inaugural speech, expressed that conference is the right place for research scholars to learn about ongoing research in their respective areas and interaction with the paper presenters or researchers and experts. He also highlighted the potential of IEEE community in terms of research, organizing conferences and related technical activities. In his address, Dr. Gangley threw a light on generative AI and summarized the pros and cons of the technology to the mankind. Sri G.S. Narayana Rao shared his view on advancements in the science and technology and these advancements in judiciary under the development of the society. Sri S.N. Nagaraja expressed his concern about information security and privacy and the opinion that research community should standard API for internet. This was followed by the second innovative talk, aggregative multiple internet connections using open multipath TCP router by Dr. Mohan Mohit BP, Unity ke Suratkal. The second day has 6 paper presentation sessions were conducted. This day had 3 innovative talks. 2 had been scheduled in the morning. The first was handled by Dr. Gangli on strategic supervision of cyber propaganda. This was followed by talk on innovative and innovation mindset by Miss Jnanapriya C. Mpcit, Bangalore. The final innovative talk was AI and machine learning in wireless network by Mr. Anandya Saha, Vice President, Wireless Status Networks, Bangalore. Finally, the 2-day conference went on very well, and we hope that event gave platform for participants to present their research work and interact with the expert. We wish again same participation in the upcoming conferences at Jnnce. Thank you, Ananda.
Thank you, sir, for providing the brief report. We are delighted to have Mr. Anindya Saha as our Honorable Chief Guest and Ms. Jnanapriya C as Guest of Honor of the Validity Ceremony. On behalf of Jnnce, I request our Chief Guest Anindya Saha, Vice President, Tejas Networks, Bangalore, and our Guest of Honor Jnanapriya, Associative Vice President, Infosys Bangalore, to accept felicitation as a token of our gratitude. Thank you all. It is said that great leaders create more leaders. Today, we have the privilege of learning from one such remarkable individual, Mr. Anindya Saha. I request you to address the gathering.
Thank
faculties and how it helps all of us. The fragrance of flowers spread only in the direction of the wind, but the goodness of a person spread in all the directions. With this, it's our privilege to have Ms. Gnanapriya with us. I request you to address the gathering.
Thank you. Hi everyone, dignitaries in the dais and students and faculty members. It has been a great pleasure for me to be here in the campus and also be part of this great conference. I think 2 days you would have got all the intellect inputs from different speakers, both internal and external, right? And you would have got a variety of insights, right, on different technologies and how you can adopt in your journeys. So my only request will be to see. I know it is more of AI ML data that is taking you further for doing more projects, etc. But my only request will be look at as a combination of communications plus compute together, and that will really take you to places. And all the very best. And the other thing what I would like to highlight as part of ComSoc also, right? Like we do a lot of this industry academia collaborations, right? And that is what is the beauty of IEEE ComSoc Bangalore chapter. We have like equal presence of both industry and academia. So you try to hear whatever we are suggesting, providing you as through lectures or like through discussions. It is like what is actually required in the industry, what is happening in the industry, we are bringing back to the academia. So this will also help you to focus on what kind of projects you can do, whether it is your undergraduate program or postgraduate program. Like if you are looking at what is really required in the industry and then do it as part of your projects, it will actually help you. And all the very best for your exams and for your future. Thank you.
Thank you, ma'am, for your inspiring words. A leader is best when people barely knows his exist. When his work is done, his aim fulfilled, they will say, we did it ourselves. With this note, I request Sri D.G. Ramesh, Sir, Treasurer, NES, Shivamogga to address the gathering.
Good afternoon. Namaskara. Esteemed guests, distinguished faculty, brilliant minds, and innovators. As we draw the curtains on this remarkable two-day international technical seminar, a sense of fulfillment and anticipation fills the air. You have witnessed a confluence of brilliant minds, a symphony of ideas, and a celebration of innovation. Participants have delved into the cutting-edge frontiers of multimedia processing, communication, and information technology. You have explored groundbreaking research, engaged in thought-provoking discussions, and forged invaluable connections. The diverse perspectives shared by our esteemed speakers and participants have enriched your understanding and inspired you to push the boundaries of knowledge. I would like to express my sincere gratitude to our esteemed speakers. Your expertise and passion have ignited young minds and fueled their curiosity. I would also like to commend the organizing committee for their tireless efforts in bringing this event to fruition. Thank you, Dr. Satyanarayana and all the squad. Their dedication and meticulous planning have made this seminar resounding success. I was actually speaking to Dr. Satyanarayana just before. He was totally happy with the happiness of the session, two-day session. So, thank you, sir. I extend my heartfelt thanks to each and every one of you for your active participation and contribution. May the knowledge and connections gained here serve as catalyst for groundbreaking discoveries and transformative solutions. Thank you. Best wishes for the future filled with innovation and success. Namaste.
Thank you, sir, for your kind and sweet words. A genuine leader is not a searcher of concerns, but a molder of concerns. So So I request Dr. Vasudeva, Chair, IEEE Mangalore Subsection and General Chair Mpcit 2024 to provide closing remarks of the conference.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Dignitary son and love the text. I'm back again. And this time he has not told 2 minutes. So, anyway, that's a great thing. But today, now we are witnessing the valedictory program. But I am sure this is not valedictory program for me as far as this particular conference is concerned, because proceedings have to be uploaded and it has to be published in IEEE Export. That is very important, right? So therefore, my role doesn't stop here, but I won't come to dais again. It is completely online. Of course, as a chair of Mangalore subsection, it is our duty. Of course, whenever the institutions want us to hold their hands, we will hand from the beginning till the end. And we will ensure that you will not be embarrassed that proceedings, when it will be published, it has not been published. What is this? What is going on? Don't worry, we will see that all 60 papers will be in IEEE Export successful. That is because why this confidence? Because you are following the process that we follow in IEEE, which defines the quality, like review process or the conference organization, all these things, right? So therefore, we should work together for that, so that 2026 version will have more papers, so that it will have a landmark and benchmark conference, so that people will wait for 2026 Mpcit to submit the papers and present their papers and publish their papers. That is the point. So I am very happy for this organization of this particular conference, particularly this team. Of course, in many colleges, faculty members used to, even Sari they have to worry about that. But these fellows did very well. I think with such a volunteer base, I think Mpcit can be done annually also. Anyway, if not Mpcit, any other conference, I think other branches, computer science, IS, AIML, lot other branches are there. I think you should think of it, because you have a very good volunteer base of students who work. That is very important. They just don't just to show off and go off, they work. Till then, so therefore definitely you can plan. I congratulate the students. I know that they have exams
we used to consider because we have to tell the rubrics also. Because if you don't tell the rubrics, ಅವರಿಗೆ ಹೇಗೆ ಕೊಟ್ರಿ ನಂದು ಭಾರಿ ಚಂದ ಆಗಿತ್ತು ಎಲ್ಲರಿಗೂ ಅವರ ಹೆಗರಣ ಅವರಿಗೆ ಮುಂದೆ. So in that case, the evaluation of the paper not started yesterday. It has been started with the review only. The review that is being given by 3 reviewers on the paper on which acceptance or rejection was made. That review score has been considered, and usually we will calculate it out of 3 and it will be multiplied by 20. So 60% weightage for review score and 20% review score for the session chair 1 and 20% for the session chair 2. That is the rubric that we follow. And of course, today's evaluation will be mainly based on presentation, not much focus on the content. That is how we have done. So without wasting your time and my time, let me announce the award. In communication track, the best paper award goes to paper ID 137. Title of the paper is Network Intrusion Detection in Autonomous Vehicles by Namrata Vadekar et al., KLE Dr. MSc Sheshagiri College of Engineering and Technology, Kerala. Then in multimedia processing, the best paper award goes to paper ID 323 by the paper title is Visual Question Answering, Convolutional Vision Transformers with Image Guided Knowledge and Stacked Attention by Miranda Suryaprakash et al. From Mpcit.
I request Dr. Y. Vijay Kumar.
And in information technology track, the best paper award goes to paper ID 270. Paper title is Android Malware Detection Using Deep Learning Techniques by Janardana D.R. et al., Nitte Meenakshi Institute of Technology. I congratulate the award winners and wish you all the best for your research perspectives, and I wish you all the best. And with this I conclude. Thank you.
Thank you, sir, for providing the information regarding how standards are maintained in the IEEE conferences. Now, I request some of the participants and authors to share their feedback about this 2 days journey. So first, I would like to call Mr. Vidyasagar SC, NMIT Bank.
Good evening, everyone. Before giving the feedback of this conference, first I would like to introduce myself. I am an alumni of this college and 2014 passed out Mpcit student. So, one thing I really like about this college is that the way the people were treating that time, it is the same feeling I am still getting the same type of the vibe is same. There is no difference. But one thing is that the college has changed a lot with respect to the technical accreditation.
myself Sumangala. I am working in Government Engineering College, Kaveri. So at the outset, I feel very proud to be a part of this two-day IEEE International Conference. So Jnnce has provided a very good platform for me to present my work. So yesterday I had a privilege of presenting my research work, and whatever the positive feedback I got from the reviewers, so definitely they were eye-openers for me. Further, I will take care of all the queries that were put forth in order to enhance my work. And regarding the coordination, so the 2 days was a perfect organization. It was a perfect mixture of all the paper presentation sessions as well as the technical sessions carried out by the delegates. And also I should thank the coordinators, Sheila madam and Pramod sir, for humble enough to answer our queries regarding the conferences. And I'm very much thankful to all the faculty members of the Ieee department, HOD sir. And at this moment, I should also thank the Department of Technical Education, Government of Karnataka, for always providing us such opportunities to participate. And thank you very much, one and all. Thanks.
Now I would like to call Mr. Vikas N. Kulkarni to provide.
First of all, good evening everyone. There are literally no words for me today. Generally I speak so much, but today I don't have any words because I'm overwhelmed with joy. A guy sitting in Shivamogga, somewhere in Ieee cities, in third semester, it is impossible to network with someone great research scholar in Australia. All happened because of the one man and inviting me here or giving me opportunity is Satyanarayana sir. A special mention to the professor Ms. Shweta ma'am and Professor Jnnce sir for helping me connect with the professors and really helping me my admirers. Thank you one and all, and special thanks to the coordinators and all the organizing chairs and principal sir and dean sir. Thank you very much.
Now I would like to call Ms. Nara Fatima to provide her point.
Good evening, everyone. I'm Fatima from Electronics and Telecommunication Department, Jnnce, Shivamogga. I'm very happy to be a part of this IEEE International Conference on Mpcit. First of all, I want to thank all the speakers for sharing their excellent research and ideas with us. Next, all the discussions covered on all the topics were very insightful. And I personally have gained a lot of knowledge in this conference, and it has increased my interest in many topics. I look forward to explore on these topics and stay connected. I would like to thank the organizers for organizing this event and providing us the opportunity to attend this. Thank you.
Thank you, Nayara. Now I would like to call Ms. Pooja Hegde to provide her. Pradhan.
Good evening, everyone. I'm Pradhan from Department of Jnnce. First of all, I'm glad and grateful to be part of this 2024 International
speech. And my best students, he made a wonderful day today. And this type of feedback normally we not ever get. So we got a very good feedback and got a good exposure to the subject and everything. Thank you so much. And respected dignitaries, thank you so much, madam and sir. All the way you have come to our institution and made this activity as memorable one. What I wanted to convey is, please, for everyone, a small request, please don't keep full stop. Keep an comma and then start doing things. Because the thing is, people, as yesterday I told you, everyone is expecting after engineering research. Our doors are open. Whoever wants to collaborate with agencies, yes, definitely 100% we are going to do it. Already I think we will be knowing that I am moving Ieee and doing zero paper, zero cash, zero energy and zero water. In these four objectives we are working. In this aspect, if anyone wants to cooperate, collaborate, yes, we are there with all of you. And similar to that, there are two companies are there in the campus. One is Ultratech, another one is Ieee. And their modern technologies is coming to campus from there you can spread to everyone. That is an issue. So not only this, whichever way you want to collaborate with our institution, yes, we are ready. And this is very much required because the expectations of the society, especially society means here the corporate world, is growing every day. One thing is, suppose if you want to collaborate with the engineering industry and if you want to supply some product, today if you supply for 100 rupees, exact after 12 months it comes for renewal, you have to supply for 90 rupees. And then again, second day you have to supply at 81 rupees. Because 10% reduction is there. Now instead of adding inflation, industries are going to reduce it. Now if you think that it is a monopoly or putting some pressure is wrong, industry is giving 12 months time to innovate at least 10% so that you get later. Now one simple thing I felt recently, Mercedes-Benz CEO has said, when we manufactured a car 132 years back, it was used for transporting 5 members from one place to another place. Even today also our car we are manufacturing from the same object. Nothing has been changing. And today our only thing is a lot of things is happening in that area. And if you are also interested, yes, we are also interested, we will do it. And finally the success in the coming days is collaborative research. And that is only there, the only mantra is there. We are ready. And finally, on behalf of the management, especially today management represented by our President Sir, Ramesh Sir, and institution, and in particular Department of Electronics and Communication Engineering, who is heading Dr. Mpcit. So thank you very much for making wonderful. Thank you very much.
Thank you, sir, for providing scope for improvement for every engineer in his or her own area. Gratitude is the finest blossom that springs from the soul. Every celebration is an experience. The external fades away and the internal wrinkles and echoes in the most depth of our heart. We are reminded that events like this, one or milestones on the journey of life, and the reminders of God's fidelity are good. As we come to the close of our valedictory ceremony, I invite Dr. Satyanarayana, Dean R&D and Head of the Department, Jnnce, as well as Organizing Chair Mpcit 2024 to propose concluding remarks for this event.
Very good evening, all of you. Yesterday I had opened the session with my welcome address. Today I am ending with my closing remarks and a very difficult job of vote of thanks. Dignitaries on the dais
and of the dais, my dear colleagues, my dear friends, my dear student friends. Mpcit 2K24 is a successful demonstration of the teamwork. Before I present my vote of thanks, which has two different parts, because while organizing the conference, whoever has contributed, it is my real responsibility to remember them, thank them, and today's program, I should present a very short vote of thanks for the dignitaries who witnessed the program. So before I go to that job, I want to make my concluding remarks with some very interesting highlights. Normally, an inaugural program of an event starts 15 minutes late, or at least half an hour. I am very happy to present that our international conference Mpcit 2K24 as a record date started 5 minutes early. Morning sessions altogether lagged around 15 minutes, which was containing a keynote speech of Dr. P. Srinivasa, Ieee Bangalore section chair. Post-lunch session had two back-to-back invited talks by Dr. Michael and Dr. Mohit on very interesting topics of computer networks and communication. More than anything, the audience group, a fully interested audience, before the day of the conference on 12th, I was addressing my Ieee ComSoc students along with other registered student participants. I declare conference, or I agree conference is a success not by the mere presentation of various technical papers and invited talks. That anyway would happen because we have planned well, it will happen. But if the room is full with my interested students, I declare that conference is a success. So, as in the inaugural program, even in the valedictory program, the hall is full of the audience. I am really happy to be. All the online sessions very well planned, managed by the technical team led by Dr. Pramod Kumar and Dr. Sheila, with the help of the campus network admin and other staff. Primary thanks to the campus network admin Girish Manta and Satish, who saw that there is no interruption in the online presentations. A very good managed WebEx link was provided by Bangalore section. At this point of time, I thank Dr. Chengappa, who is from HP Enterprise and Exicom Ieee Bangalore section, who manages the online platform of Bangalore section, and the session coordinators, both the faculty and students. Second day, we had 2 paper presentation sessions as well as 3 technical talks, which were very informative from the industry delegates. So this was the concluding remarks about the conference today. Very brief report. Anyway, it has been read already by Dr. Pramod, but I thought that at this point of time, it's better to once again re-highlight and really present the concluding remarks. Thanks to everyone for making the conference a success. Just in the organization of the conference, a lot of stages would come, starting with the publicity. I thank Mr. Mohan, Assistant Professor Computer Science Department, who managed our website very well. Thank you very much, my friend. All the authors who submitted the papers, 333 papers we received. After desegregation, around 290 papers, 250 papers went for review. Ieee demands blind review from 3 reviewers. Totally 890 reviews were managed by the track chairs. Congratulations and thanks to my track chair team comprising of 6 faculty members from Jnnce. Thank you so much. And they have ensured that it is really blind by removing all the affiliations from the papers. All those efforts were really acknowledged from the organizing team and the Jnnce. I thank IEEE manual subsection who really technically co-sponsored, witnessing chair of IEEE manual subsection stayed here for 3 days. A big round of applause to Vasudeva who made the closing remarks and evaluated the best paper awards, because the host organization in principle should not award the best paper. There should be a person who acts as the observer and finally decides the best paper. So complete responsibility was given to Vasudeva. He managed very efficiently his own made designed Google Excel sheet which finally gives the best paper award based on review and the presentation scores. Registration team, because once the papers are selected, 102 papers were selected. After the continuous follow-up, we were successful in registering 60 papers. All these 60 papers were presented, out of which 40 were online, 45 were online and 15 were physically presented. I thank all the faculty members who really coordinated the whole process of organizing the conference very well, starting from publicity till the review and finalizing the registration of the papers. Thanks to accounting team who gave the report of the registration, whoever has paid the fees, all those details in one shot has been provided by the accounting team. Thank you so much. I thank all the organizing committee members of our department, to start with the logistic team for arranging delicious food and accommodation to the invited speakers. Technical session team coordinated by Dr. Pramod Kumar and Dr. Sheila, and all other faculty coordinators and the non-teaching staff members. Reception 10, inviting the guests for the conference led by Dr. Shanti Kiran and Ajay Beku. I thank you so much, because they have, in 2 or 3 days, they saw that there is no flaw in inviting our guests. Thanks to session chairs, both external and internal, who evaluated totally 11 paper presentation sessions. I thank HODs, my dear colleagues of across the departments, and for cooperating in all the levels, providing this particular seminar hall. I thank the civil department and all the team members who made this particular room ready for the conference. Outcome of Mpcit 4 editions are really seen. Just one to quote, I thought that Mpcit 2018 was organized by Electronics and Telecommunication Department jointly. There one author received the Best Paper Award. He is my proud student. Today he acted as session chair. So Mpcit, all the editions are growing with a proper outcome. So this is one thing which I wanted to present, organizing the conference 2 years once, because it requires 1 year preparation. We started the preparation during December 2013 by requesting the management and asking the permission and asking the budget, and it ended up on December 2024. So we thought that we organize 2 years once. Finally, it is a grand success. Coming back to the valedictory program, we thank the chief guests, Anindya Saha and Mrs. Jnanapriya, for witnessing the program. Thank you so much, madam. Guest of honor, D.G. Ramesh sir, Treasurer of National Education Society, for accepting our invitation. Our beloved Principal, Dr. Y. Kumar, a dynamic leader who always supports such programs. Thank you very much, sir. Dr. P. Manjunath, Dean Academics, my colleague, my department member, he always will be there with me for every such event. Thank you so much, sir. I thank faculty members of various departments, non-teaching staff, heads of the department who witnessed this particular valedictory program. More than anything, a big thanks to my student participants, delegates who stayed till the end so patiently and see that valedictory program is not having any empty seat here. So really it is a great moment to cherish. Thank you so much, my friends. Finally, a big thanks to my team, faculty and non-teaching, once again to close. Every event I plan and propose in my faculty meeting and staff meeting, they will be there, they will be joining hands. Till the end, they will be there in every stage. Just for formality's sake, we make organizing committee, but irrespective of the committee, they will be there with us. A big thanks to my friends, my department friends. Thank you so much. Finally, just to make a remark, honestly, if any organizing related error has cropped in, really it is not intentional. Lot of thought process gone into. With the available scope of management of Mpcit 2024, I really declare that it is a successful organization. The next version, Mpcit 2026, is planned to be scheduled during August-September 2026. We are planning 2 months early because Feb and December we are facing various problems of receiving papers because December is full of conferences. On the same day, conference was there in MIT as well as in Jnnce. So at least for getting good number of papers and for having some breathing time, I thought that let us prepone for 2 or 3 months. So next version of 5th edition of Mpcit 2026 will be organized during August-September 2026 with the kind permission of our management at Mpcit. Thank you so much. As organizing chair of the conference and signing off, High Tea is arranged outside. Thank you so much for the patient listening. Thank you.
support rendered in the success of this valedictory session. Thank you, everyone. Have a wonderful and fun-filled evening. IT is arranged and I request all of you to have. Thank you.
For students, bus